Hi, I'm Adriana Lee, here for RUTV. I'm at the Hill Center visiting the Rutgers Laboratory for Real-Life Reinforcement Learning. Professor Michael Littman and his graduate students work together on making programs for robots to recreate human learning. So, in the same sort of way that I'm learning how to maneuver this sort of thing, they try to recreate programs in their laboratory to do the same thing. Let's go inside and take a look.
The high-level goal that we're trying to accomplish is essentially to create a different way of programming computers, if you will. Mostly the way that people program computers today is by giving them very explicit lists of instructions. Do this, do this, do this, do this. These very explicit lists of instructions are a little bit too limited. And so what we're trying to do is come up with ways of programming robots instead of by instruction, by desire, by almost emotions.
I was eager to see these robots in action and asked Professor Littman to describe the demonstration.
As far as we know, the best way of getting an intelligent agent to come into the world and be able to act intelligently is by giving it a sense of what it wants, what it's trying to do. The first demo is to get to a particular location while avoiding an obstacle. And to make things particularly tricky, we have that obstacle moving. And the robot needs to figure out which of the 6 behaviors it can do. It can move forward, it can move backward, it can turn left, it can turn right, and it can strafe left and strafe right. So it tries to figure out how to piece all those little behaviors together so that it can make it to the goal location while avoiding the painful stimulus, which is the little bumble ball that we have. We are not hardware people. We don't build robots. So by and large, the robots that we work with are off-the-shelf technology.
The robots themselves are made up of 3 parts. First, the physical moving robot. All of the real work, though, such as the major computing and programming, takes place in 2 separate locations. All of the information is processed through an overhead camera and linked to a laptop computer that has motion detection software. The original programming and directions originate from a much larger, more sophisticated computer. All 3 aspects work together simultaneously to create this learning experience within the robot. Each time the robot goes through a demonstration, it remembers what it learned in the previous session and applies it in the new situation in order to reach its goal in a more efficient manner.
For us, the movement is the most interesting thing, because by moving, they're actually changing the environment that they're in, and that can bring up other issues that they need to deal with. And so that it makes for very dynamic, interesting kinds of test beds.
While all of these parts may seem abstract to an outsider, Professor Littman has hopes for these little robots.
Even though we haven't been focusing on applications, ways that we can actually, say, sell this or use it to make people's life better in the next year or two, we are very committed to this idea of running the programs in realistic environments, because that's going to enable these kinds of applications.
Well, it's been a very informative and exciting afternoon. If you would like more information on the Rutgers Laboratory for Real-Life Reinforcement Learning, you can go to www.cs.rutgers.edu/RL3. I want to thank Professor Littman and his graduate students for all of their help. It was very exciting and interesting. I'm Adriana Lee for RUTV.